Good morning, my dear students. So in this class I'm going to tell you about, again I am going to solve the problems on V engine. Okay, so this problems comes under balancing of reciprocating masses. Okay, in the last class we solved about the problems on secondary balancing, that is the inline engine problems. Okay, so now in this class I'm going to tell you about the how we are going to solve the problems on V engine. Okay, so in the previous class I told you what you mean by V engine. Okay, so V engine is nothing but V engine sometime we are going to call as a normally V engine. So it is a common configuration of an IC engine, that is IC engine combustion engine. Okay, so it consists of two cylinder banks, usually with the same number of an cylinder in each bank. Okay, so connected to the common crankshaft is called as V engine. Okay, so now we are going to solve this type of that is V engine problems. Okay, so question is given like this: a 90-degree V engine has a two cylinder. Okay, so normally V engine consists of two cylinder only. Okay, a 90-degree V engine has a two cylinder which are placed symmetrically. The two connecting rods operate in a common crankshaft. Okay, the length of the connecting rod are 400 mm each, and the crank radius is given 100 mm. The reciprocating masses per cylinder is 4.8 kg. If the engine speed is 1200 rpm, then find the resultant primary and the secondary forces induced in the V engine. Okay, so also find the maximum resultant secondary forces. Okay, so here this is about the question they given. So this type question are very important. They may ask you around 8 to 10 mark question. Okay, so given data is given what 2 alpha is given what that is a 90-degree. Okay, so why we are going to consider here as 2, because it has already consist of two cylinder. Okay, so mass is given 4.8 kg, and length is 400 mm is given, radius is given 100 mm, and speed is given 1200 rpm. Alpha is equal to 45 degree. Okay, so omega is equal to, so this is about the question given. Okay, so we need to calculate the angular speed. We have the formula omega is equal to 2 pi n by 60. So substitute n is equal to value 1200. You are going to get what omega is equal to 125.66 radian per second. So we have the oblique ratio formula, that is small n is equal to length by r. So 400 by 100 is equal to what 4. Okay, so first you read the question, so note down the given data. So what they not given, so you calculate with an angular velocity, that is angular formula, and the oblique ratio. Okay, so now we have the formula, direct formula, that is resultant primary force is equal to, it is a primary force is equal to what, so 2m r omega square root of cos square alpha into cos theta whole square. Okay, plus sin square alpha sin theta whole square. Okay, so we have the 2m r omega square. Again the alpha is given, that is in V engine normally angle is what, so otherwise you calculate alpha is equal to 90 by 2, you are going to get 45. Okay, so here cos square 45 into cos theta plus sin of square alpha is equal to 45 and into sin theta whole square. Okay, so again Fe, that is a result primary force, is equal to 2m r omega square root of here cos square theta into cos theta whole square is equal to what, cos theta by 2. Similarly this also sin theta by 2 whole square. Okay, so here primary force is equal to m r omega square divided by 2 is equal to square root of cos square theta plus sin square theta, if you take the 2 common outside. Okay, so remaining what you are going to get here, m into r into omega square. Okay, so if you substitute all the values m into r into omega, so you are going to get 7579.4 Newton. This is the resultant force induced in the V engine, that is primary force. Okay, next is resultant secondary forces. Okay, so we have the direct formula here. Okay, secondary force is equal to 2m omega square r divided by n square root of sin alpha into sin 2 alpha sin 2 theta whole square plus cos alpha cos 2 alpha cos 2 theta whole square. Okay, so we already calculated the V engine derivations. Okay, so that from that only we are going to take the direct formulas. Okay, so here secondary force is equal to 2m omega square r divided by n, so square root of, again you have to, here the angle is given, that is alpha is equal to what, 90 degree. Okay, so here 2 alpha is given, take 90 here in place of. Okay, whereas alpha is there 45 degree. Okay, so sin 45 degree into sin of 90 degree sin 2 theta whole square plus cos 45 into cos 90 cos 2 theta whole square. Okay, so if you again you simplify that, you are going to get 2m r omega square divided by n, so square root of 1 by root 2 into 1 into sin 2 theta whole square. Okay, so plus 1 by root 2 into 0, that you are going to get 0 only. Okay, so f of s, that is secondary force induced in that. Okay, 2m r omega square divided by n into sin 2 theta divided by root of 2. Okay, you are going to get the secondary force induced in the V engine is 2679.72 sin 2 theta into n. Okay, so here what we need to calculate is theta also need to calculate. Okay, so this V engine what I wrote, I taken the direct formulas, that is we already derived what you mean by V engine and what are the equations comes under the V engine. Okay, so from that only we are going to consider the formulas. Okay, so before solving the V type of engine, you read the what you mean by V engine and what are the list of formulae I mentioned in the notes. Okay, so here third one is maximum resultant secondary forces. Okay, resultant secondary forces will be the maximum. Okay, that is sin 2 theta is equal to 1, therefore theta is equal to what, 45 degree. Therefore the f of s maximum is equal to 2679.72 into sin theta into 90 degree. Okay, so that we are going to get 2679.72 Newton. Okay, so this is the maximum resultant secondary force. Okay, so this is about the problems on V engine. Here you have to remember the three formulas, that is a primary force, secondary force, and the maximum force. The maximum resultant force nothing but what, the resultant of the secondary forces will be the maximum. Okay, so that you have to take, again you substitute the formulas, so you are going to get what here. Okay, so this is about the V type of problems engine. So very simple. So you have to remember, the only thing is you have to remember the formulas. Okay, that is very important here. So they may give you mass, radius, alpha, speed. Okay, everything they may give in the given data, just to analyze and what formula you are going to apply, that you apply, so you are going to get the answer. Okay, so I will repeat here. In the V engine you have to remember the formulas of primary force, that is a secondary force, that is a both of resultant and maximum force. Okay, these three formula you have to remember. Okay, so then only you have to going to solve this type of problems. Okay, so V engine. Okay, so I will repeat again. So here you read here the last one, other may have confusion here. So third one is the maximum resultant secondary force is asking, that is maximum resultant secondary force is nothing but what, resultant of secondary force will be the maximum. Okay, when sin 2 theta is equal to 1. So just to observe here in the last values, sin 2 theta into, that is, if that is comes means that is also the resultant secondary force of will be maximum. If it is not come sin 2 theta, that is not. Okay, so sin 2 theta is equal to 1. Okay, if you so sin 2 theta is equal to 1, if you means you are going to get 90 degree. Okay, so that you have to put here f of s is equal to maximum of 2679.72 sin 90 degree, that is 2679.72 n you are going to get. N is not the force unit, that is Newton. Okay, so I hope you understand this type of problems. Okay, so V type of problems are normally they may not ask in the examination, that they may ask you only the problems on secondary balancing, that is inline engine. Okay, so you have to need to construct the primary force diagram, secondary force diagram. Okay, so you have to calculate that. Okay, so I hope you understand these problems on what is the balancing of reciprocating mass under problems on V engine. Okay, so I hope you understand this. Thank you.